Well, welcome to lesson 1.9 on transformations, and we're going to look at transformers. Three types of rigid transformations are translations, rotation, and reflection. And throughout this textbook, you'll have what's called coordinate geometry 1, 2, 3, 4, 5, so on. And this will be the foundation of those. So there actually will be a coordinate geometry 1. There's coordinate geometry 1 in this textbook, in this chapter that we'll go over. So a translation involves some sliding or moving an object along a straight path, and that path is represented by a translation vector. Well, what's a vector? An arrow, and it has direction and distance. So a certain direction, a certain distance. That's called the translation vector. Translations are often written on a coordinate grid, as shown below. This grid has a very specific type of labeling. Notice you have triangle ABC, and that's the original. The image is called triangle A prime, B prime, and C prime. The apostrophe means prime, not to be associated with Amazon Prime, just prime. You can also have, if you were to take that red triangle and move it again, you could have double prime. That would just mean you moved it a second time. Secondly, you also have rotations, where all points of the original figure are turned or rotated. Let's say rotate. Identical number of degrees, either clockwise or counterclockwise. And counterclockwise is the default direction if it's not given. Here, you can model the rotation by tracing over a figure and then putting your pencil on a point on the patty paper and rotating the patty paper out the origin. We'll do this in class. Reflection produces an image. That's the third one. So reflection produces an image, which is the mirror image of the original figure. And this is key. Every point and its image are on the opposite side and the same direction and the same distance from a fixed line called the line of reflection. Okay. So if you have a line here and a point, let's say this is called A, and then the image of that, we'll call that A prime. So it's going to be, it's 2 away here, it's going to be 2 away here. And it's going to be exactly opposite on that line of reflection, just like you were to fold it over and the crease would be that line. That's a reflection. So let's do an example. So on a coordinate grid, you're going to graph the following triangle with the vertices. Go ahead and make a grid, make it XY axes, label A, B, and C, plot the points, draw the triangle, and then do these 3 transformations, and then watch my video after you've attempted on your own to get a solution. Okay, so I went ahead and plotted ABC on the coordinate grid. Now I'm going to reflect the triangle along the y-axis. So what is my line of reflection? The y-axis. And starting with point A, how many units is A from the line of reflection? Well, it's 2 away. Okay, so I'm going to put it 2 away on the other side and call that, we'll call it A. I'll call it A prime. mean it's the image. Okay, so how far is B from the line of reflection? 2. And so I'm going to put B prime over here. How far is C from the line of reflection? 3 units. So C prime. And I have my reflection. Translate means to move or to slide the triangle 2 units to the right and 3 units down. So 2 units to the right, 3 units down. What's my translation vector going to be then? It's actually right here. So that's the translation vector, and every single point will be moved that distance and that direction. So 2 to the right, 3 down, and this is going to be called a prime, no, a double prime, right? A double prime, and then B, 1, 2, 3, B double prime, and then C to the right, 1, 2, 3, C double prime. I'll go ahead and draw on the triangle. There we go. Okay. Finally, rotate the triangle 90 degrees clockwise about the origin. So this is all done visually right now. Imagine in your mind you were rotating this. You could almost imagine you're turning. If you take your computer, like if you have a cell phone right now or something, and if you were to take it and rotate 90 degrees, whatever image you get, that's what you want. I could even take my screen right now and rotate 90 degrees, and that would tell me exactly what it's supposed to look like. So what you'll get when you do that is C triple primes right there. Let's see here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. B triple prime. And then A is 4 to the right. And there's your rotation. Okay. Well, that concludes that one. Finally, one more concept. Rotational symmetry is the property of a figure when it looks the same after some rotation by a partial turn. So, for example, you could have the letter I. And if I rotate I 180 degrees, it still looks like an I. So that has rotational symmetry. But A, I would have to rotate it 360 degrees to get back to the original A. That does not have rotational symmetry. So what letters can you think of that have rotational symmetry? Does B have it? Nope. C? Nope. What about H? Yes, H does. What about S? Turns out S does, X does, C does, and there are 2 more that do. See if you can figure out what they are. Okay, well, that concludes lesson 1.9 on rigid transformations, translation, rotation, and reflections. And remember, without geometry, life is pointless. Have a good day.